Good morning, children. Today we are going to start the third chapter, metals and non-metals. In this chapter, we are going to compare the physical properties of metals and non-metals, then chemical reactions of metals, how do metals and non-metals react to each other, then the extraction and refining of metals, also corrosion and the ways to prevent corrosion. Alright, so now we will move to the first part of the lesson, the comparison between the physical properties of metals and non-metals. Let's move to the chapter.
Alright children, today we are going to discuss chapter number 3, metals and non-metals. This is the periodic table. The periodic table is classified into metals, non-metals and metalloids. You can see the red colored elements in the periodic table are metals, and the blue colored elements are non-metals, and the yellow colored elements are metalloids. Metalloids means they show at the same time some of the properties of metals and also some of the properties of non-metals. So when you analyze the periodic table, you can see most of the elements in the periodic table are metals. So today we are going to compare the physical properties of metals and non-metals. Right? So the first property is appearance. Appearance means how do they appear? Shiny or non-shiny, etc. We know that metals appear lustrous. Lustrous means shiny. Non-metals are dull in appearance. So here are the examples. You can see metals, gold, silver, etc. are very lustrous, very shiny in nature. While carbon, see here in the picture you can see carbon. Carbon is a non-metal which is dull in nature. In all cases, exceptional cases are also will be there. Right? So for example, lead is a metal which is non-lustrous in nature. While iodine is a non-metal, here you can see, which is very shiny in nature. This is iodine. Right? So moving to the second physical property, hardness. So we know that metals are hard in nature while non-metals are soft and brittle. Right? Brittle means easily breakable. Let's see some examples. See here, gold, silver, etc. They are hard in nature, while if you hit with a hard object, non-metals will break into powder or easily breakable. Here also exceptional cases are there. See, sodium is a metal which is very soft. You can cut even with a knife. You can see in this example, cutting with a knife. This is sodium metal. Non-metal here, it is diamond, which is a form of carbon, which is very hard in nature. The hardest substance on earth is diamond. Moving to the third physical property, malleability. Malleability means the ability of an object to make that into thin sheets is called malleability. So metals are malleable while non-metals are non-malleable. Example, see here, we can make thin sheets of gold. Right? In the picture you can see if we try to hit with a non-metals are non-malleable. They will become powder. Here also exceptional cases are there. In the case of sodium, sodium is a very soft metal which is non-malleable. The fourth physical property is ductility. Ductility means the ability of an object to make that into very thin wires is called ductility. So here metals are ductile while non-metals are non-ductile. You can see copper. Copper is made into very thin wires because it is ductile. So generally metals like silver, gold, copper, etc. are ductile. They can be drawn into very thin wires, while non-metals like carbon, sulfur, etc. are non-ductile. So here also exceptional cases will be there. Sodium, potassium, lithium, etc. are very soft metals. They cannot be made into very thin wires. Moving to the fifth physical property, sonority. Sonority means the ability of an object to make a particular sound, a ringing sound when hit with a hard object. Okay, it's called sonority. So metals are sonorous and non-metals are non-sonorous. Here you can see some examples are given. Metals, for example, school bell is an example for a sonorous substance. Moving to the sixth one, sixth physical property, heat and electrical conductivity. So we know that metals are very good conductors of electricity while non-metals are poor conductors of electricity. Metals like gold, silver, copper, etc. are very good conductors while non-metals are bad conductors of electricity. For example, charcoal is a poor conductor of electricity. Okay, the most silver is the best conductor of electricity and second place is for copper. So, exceptional cases are there. For example, metals like mercury, lead, etc. are bad conductors of electricity. And in the case of non-metals also, exceptional cases are there. For example, graphite, which is a form of carbon, is a very good conductor of electricity. So here moving to the next physical property, state. Okay, metals are generally solids. Okay, non-metals can be exist as solid, liquid, or gas. And let's see some examples. Here you can see metals like silver, gold, zinc, magnesium, copper. Many examples are there. They are generally solids. Okay. And you can see non-metals like carbon, sulfur, iodine, etc. exist as solids, while bromine is the only one liquid among non-metals. And a lot of gases are there like oxygen, hydrogen, helium, argon, krypton, xenon, chlorine, etc. are examples of gases. Okay, exceptional cases are there. For example, mercury is the metal which is in liquid state. Moving to the eighth property, nature of oxide. So we know that metal oxides are basic in nature. For example, MgO, CaO, sodium oxide, etc. are basic in nature. When they dissolve in water, they will make hydroxides. Okay, while the oxides of non-metals are acidic in nature. For example, sulfur dioxide, carbon dioxide, nitrogen dioxide, etc. So that's all about the physical properties of metals and non-metals. In the coming class, we will discuss the chemical reactions of metals. Right? Have a nice day.